Hello everyone and welcome to today's class of competitive programming in C++. Today we'll be discussing a few abstract topics. You won't find these topics anywhere because this is not a part of core C++, neither is this a part of what do you call it? Basics of C++. The reason why we have to study these two topics is because if you get in touch with these now, if you get familiar with these topics now, it becomes easier for you down the road. When you start solving problems, you will understand what's the meaning of constraints and how do I overcome constraints, because there's another topic called as overcoming as well. So before we jump right into today's topic, we'll brush up a few concepts from yesterday. I hope you remember bits slash std c++.h. I hope you remember name using namespace std. I hope you remember all this stuff. I hope you remember bool keyword, its specialty, that zero is false, everything else is true in bool. And I hope you remember ASCII values. Capital A. Let's recall the ASCII values again. ASCII. Capital A is actually 65, and let's take the symbol of and. Okay. And small a is actually 97. The reason why ASCII values are actually pretty important, I've already demonstrated that in the previous class, but let us take another demo. This is a snippet that I've created. If you want a guide on how to create snippets, let me down in the comment section and help you out. Okay. So I have, let's take C out of A plus 1. What do you think is going to be the output of this particular program? Have a guess. I don't want you to be correct. I want you to have a guess. If you guess the answer was B, you're wrong. If you guess the answer was capital B, you're wrong. If you guess the answer to be 98, you're absolutely correct. It's going to give me 98. Why? Because A is 97, the ASCII value of A is 97, and the ASCII value of A is stored here. This is not a string, this is the ASCII value. This is a string. This is not a string. Okay? I hope you understand the difference between ASCII value and a string. Now, we'll jump into this first topic, which is precedence order of data types. Precedence order of data types is actually not that relevant, but you need to understand that always double is greater than int is greater than float. What do I mean by this exactly is that if I have three integers double a, int b, float c, and if they are in the same function or if they are in the same line of code, double will get executed first, then int, then float. This might sound very simple at first. You might not find any applications of it right now, but when we dig deep in competitive programming, this actually plays a very important role, and I hope you don't forget this precedence order. And now today's main topic, overflow. Before jumping directly into overflow, I'll give you a very quick intro. Int can hold values up to 10 to power minus 10 to power of 9 to 10 to power of 9, 10 to power of 9, and uh, long int, wait, let me just, long int can hold values up to 10 to power of minus 12 to 10 to power of 12. Similarly, long int, once again, it can hold values up to uh, 10 to power of minus 18 to 10 to power of 18. Now you might wonder, why is this actually important? We have for double as well, but double, what happens in double is actually, I'll tell you, when double is actually massive, it's very large. It's a very large number. So as the size of number increases, I'll write this here, as the size of number increases, the accuracy of the result output decreases. For example, you're doing a calculation and it requires around, let's say, a billion numbers. Let's say it requires a million or a billion numbers. You might have an output, but the accuracy to that output might not be absolute. You might not get 100% accurate answer. So that's why we prefer not to use double in any question in competitive programming or in C for that matter of fact. Do not use double, avoid double, use int, long int, or long int. Now, why do we require these values which I've given you 10 to the power of 9, 10 to the power of minus 9? Okay, I'll show you here. Let us take int a equal to some very massive number and see out a times a. What do you think is going to be the output? This is actually 1, 2, 3, 4, 5, 6. So there's 6 here, right? The output has to be 10 to the power of 6 times 10 to the power of 6, which is equal to 10 to the power of 12. But it's not going to be 10 to the power of 12. Watch. It's giving me some garbage value. Why? Int can hold up numbers from 10 to the power of minus 9 to 10 to the power of 9. And since 10 to the power of 12 is greater than 10 to the power of 9, 10 to the power of 9, it overflows. Int overflows this particular number. Now, why do we need this? I'll explain in this video. Now, if I go with long int or long int, it's going to give me 10 to the power of minus 2, 10 to the power of 12. No issues. Now, you might wonder, why do I actually need this? Let us go to lead code. Uh, Let us take this question, any question, two sums. And here you will find, can you please scroll down? Yeah, you will find constraints. There are constraints to each and every question, and if you don't match those constraints, your answer is absolutely invalid. Your answer doesn't hold the proper constraints, thus your answer will be deemed as invalid or incorrect. That's why you need to follow these constraints. Now, if you want to use int and compute this, how do you think we can do this? I can just multiply it by 1 ll. It's going to give me, no, why is it giving me garbage value? 1 second. Wait, I'll change this later. You can actually convert this to long int if you want very big numbers, if the calculation of the number is absolutely massive or abnormal. And if you want to convert it, you can just go, and if you just type times 1 it's again giving me a garbage value. It should actually be printing 10 to the power of minus 12, because here LL actually means long. So you are multiplying this current output by long. So it's actually going to give you 10 to the power of minus 12. Do not use double. Avoid the usage of double in while declaring variables. You might think the larger the better. No, it's not. It's not the case in C++. And if you want to like remove like scientific values, like if you go with long int, and I'll go, wait, I'll go long int and take a as a very humongous number. It's giving me a garbage value again. And if you want to, if there's any scientific value like e or like I or something, and if you want to remove that value, you just go fixed, and it's going to be fixed. Since there are no scientific values here, it won't show me anything. Okay. And if you want to remove decimals from like the given output, what you basically do is you just say set decision, and you basically remove all the decimals. So I hope you understand the usage of or the importance of constraints, overflow conditions, and why do we require them in programs. I'll be discussing about that in while we discuss time and space complexity as well. And if you have any doubts regarding anything else in any other programming language like Java, Python, please make sure to inform me about that in the comment section. You can ask me those doubts, no issues. And that's it for today's class. Thank you. Bye.